Hello. Hello, Hashima. Just wanted to go over the first examples from lesson 99, problem solving with expressions. Mr. Levine posted a written version of this, so if it's easier for you to just look at the written one, that's fine. This is a lesson in which we are going to really look at how to interpret problems involving expressions. Interpret just means to think about the size of something or to make an inference about it. And when we look at expressions, we're talking about different equations that can have more than one step. So fact number one is that we can interpret expressions without having to solve them. Just like you know that 100 times 100 is going to be a big number and 1 times 2 is going to be a pretty small number, you can make pretty good guesses about what an expression is going to equal without actually solving it. Fact number two, we can use parentheses for multi-step problems. There's 3 different kinds of parentheses. You've got the traditional ones, and then you have braces and brackets also, so make sure that you look for all 3 of those types. And then when you're multiplying, you can predict, this is fact number 3, the size of the product. So when both factors are greater than 1, the product is also going to be greater than both factors. So if you are dealing with 2 numbers that are whole numbers, your answer is going to be greater than both of those. But if you've got at least one factor that's less than 1, the product is also going to be less than one of the factors, the bigger one. So when you're dealing with a proper fraction times a whole number, it's going to be less than the whole number. So this is a way for us to think about what the answer is going to be to help us see if our answer is going to make sense. So looking at example A, and again, this is posted in Mr. Levine's version as well, we've got a word problem that says that a bag of trail mix contains 1/4 a cup of sunflower seeds and 2/5 of a cup of pumpkin seeds. If Jerry has 4 of these bags of trail mix, how many cups of seeds does he have in all? So as you can see, what I did first is I have 3 bullet points for the 3 numbers in the problem. I listed out what each of those numbers mean. 1/4 stands for the cups of sunflower seeds, 2/5 stands for the cups of pumpkin seeds, and 4 stands for the numbers of bags of trail mix. And then I've drawn a picture here of 4 bags, and I put an S and a P in each bag. S stands for sunflower seeds, P stands for pumpkin seeds. So you can see in 4 identical bags, you have the same contents, 2 different types of seeds. So when we wrote the expression, we used parentheses to bracket the addition. You're adding the sunflower seeds and the pumpkin seeds to get the total number of seeds in one bag. Then outside of the parentheses, you're going to multiply that by 4 because there are 4 identical bags. So here's what I want you to do. Don't look at the multiplication yet. We're just going to first do what's in the parentheses. So in order to add 2 unlike fractions with different denominators, you need to write vertically and then rename them. So I did a common denominator of 20, so 1/4 becomes 5/20. 2/5 becomes 8/20. Notice that I showed that I multiplied by 5 here and multiplied by 4 here. 5/20 plus 8/20 is 13/20. So that means that each bag of trail mix has 13/20 of a cup of seeds. Then you're going to multiply that times 4 because there are 4 identical bags. Now you're going to look at the multiplication over here. So thinking about what we said about interpreting the size of the product, each bag has less than 1 cup of seeds in it. 13/20 is less than 1. So when you multiply that by 4, that means your answer is going to be less than 4. You are shrinking the 4 down because you do not have a whole cup of sunflower seeds and pumpkin seeds in each bag. So set it up just like you would with any fraction times a whole number problem. 13/20 times 4. Make sure that you give the whole number a denominator of 1. Rewrite it, then do 13 times 4, which I showed up here is, 52. And then 20 times 1 is 20. So 52/20. We can turn that back into a mixed number. 20 goes into 52 2 whole times. You've got 12 left over because 52 minus 40 is 12. And your denominator stays the same, 20. This can be reduced to 2 6/10 and then even further to 2 3/5. So that final answer is 2 12/20 or 2 3/5. If that did not make sense, please either rewatch or look at the document that Mr. Levine posted. Let's look at example B. It's kind of trickier because example B is like a thinking problem. So it says someone's playing a math game and they have to multiply 2 numbers, A times B. Which statement has to always be true based on the criteria below? Number A is a mixed number. Remember, all mixed numbers are greater than one whole. B is the number 1, 2, 3, 5, or 10. That means that no matter what, B is going to be a whole number. So just thinking about what you know about multiplying mixed numbers and whole numbers, they're both quantities that are more than 1. So that means your answer also has to be more than 1. So Mr. Levine has a really great example of this online, so I'm not going to talk about this one as much depth, but basically you should test out each solution. So the product, choice A says the product is exactly double number B. Now, the only case where the answer would be double number B is if the second factor is 2. But sometimes the second factor is going to be 5 or 3 or 10, and in that case, A would not be right. It's not always going to be double number B. Choice B, the product is a whole number that's less than both A and B. That can't be true because if you're multiplying two numbers that are greater than 1, your answer is not going to be less than both of those numbers. C, the product is less than number A. That also is not going to be true because number A is a mixed number. Both numbers are bigger than 1, so the answer is going to be bigger than both of them. So D is the only one that can be right. The product is greater or equal to number A. We know that because when the two factors are both greater than 1, the answer is going to be greater than each factor. So, a little complicated. Check out Mr. Levine's version that has everything tested out on this because I think it might be a little more clear. But I hope that this video helped make some sense of this lesson, and you're going to go ahead and try Are You Ready and work it out on Google Forms.